All right, so I have already uploaded the lecture materials on iLearn. We're gonna do another problem in simulation models, Monte Carlo simulation. So let's go ahead and do it. Any question or comment before we start? All right, so let's go ahead. So this is still chapter 11, simulation models part 2. We did part 1 before the Thanksgiving. One of the applications that we can use simulation models for is finance and financial problems. So for this, you might need to know a little bit of finance as well. I mean, the material, the things that we're going to talk about, it's not that difficult. So we can just start from here. So in this problem, we're going to work on the financial situation for the profit, the present value of the profit that a car company is going to make for like 5 years that want to make a new car. Okay, so that's an example of financial situation or simulation application for a finance problem. All right, so there are many financial situations where simulation can be helpful. You can use simulation to estimate anything that deals with finance problems that have uncertainty and stochasticity with them. For example, estimating the average and the variance of a project net present value or the company's profits next year or next couple of years, or the net present value for that, and the probability that a project can get a negative present value, or the likelihood that a company will have to borrow a certain amount of money, for example, next year. And the fifth or 95th percentile, the fifth percentile is called also the value at risk, or VAR, that we're going to see actually in this example. So this is a problem that you want to work on. The new car development at a company called GFAC. So suppose that they want to introduce a new car, build a new car. They have estimated certain information and data based on consulting with their accounting, marketing, and engineering departments. For example, the fixed cost, the fixed amount of money that they would need to develop the car, the margin per car, or the contribution per car, the unit sales for different years, estimation, depreciation and taxes, and the discount rate to calculate the time value of money. The goal is to estimate the expected net present value for the next 5 years, and also to estimate the probability of getting a negative present value for the new car. So these are the data that we would work with. The fixed cost for developing the car is estimated to be $800 million. The contribution or the margin per car is computed as the price minus the variable cost, and it's actually a variable cost for a stochastic value. It's going to change. So for example, for the first year, they estimated to be $4,000, but it's going to drop by 3% each year after that. It says in year 1, they estimated to follow a normal distribution with an average of $70,000 and a standard deviation of $5,000. But after that, they expect that to actually drop, following by a rate of that follows a uniform distribution within 5% and 10%. Okay, so it's a combination of normal distribution and uniform distribution. Okay? And also we need to compute also the depreciation. The depreciation here is estimated to be fully applied for 5 years. So that means that 1/5 of the fixed cost of developing a car. The corporate tax rate is 21%, and the discount rate to compute the time value of money when we use net present value formula is 6%. All right, so let me open up the Excel file. You can also open up the sim models new car data and follow along as I do here. So this is the data file. We have all the data here. Certain steps have been done to make the model to be run faster. So here you can see the input data. We have fixed development cost that is estimated to be $800 million for the car. The first year contribution or margin for the car is $4,000. So for the next 5 years, we need to estimate that, compute that by knowing that it's going to drop by 3%. The tax rate is 21%, and the discount rate is 6%. So first thing first, I'm going to use range names for these values. I'm going to name them. And here you see the distribution, uncertainty distribution for the sales, and also for the sales for the normal distribution and for the uniform distribution, which are used for car sales. Right. Okay. So now these are the years, the next 5 years we want to compute that. The first thing that we need to compute is the unit sales. So unit sales for, as we said, it follows a normal distribution. So I'm going to use the norm.inv, norm inverse, and then you're going to use the rand function to generate a random number. And then I'm going to give it the mean, the average of producing cars, which is 7,000, and also the standard deviation, which is 5,000. So this is going to give us the unit estimation for sale in the first year. Okay, so I'm going to make this a whole number. This is actually a random variable, so I'm going to make it use the random variable style for it. The next year, the second year, it follows also a normal distribution, but it's going to be discounted by following a uniform distribution. So this is going to be this one multiplied by 1 minus the uniform distribution value. So that would be the mean value plus max minus mean multiplied by the rand function. And I'm going to use this format painter for this as well. So now I can actually drag this to the 5th year. So as you can see here, to make sure that this actually works, for the first year, it's 68,000. For the second year, is just going to decrease, 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 and decrease, because if the decrease follows a uniform distribution between 5% and 10%. All right. So that's the unit sales for car for the next 5 years. We need to also compute the unit contribution. So the unit contribution for the first year, we know that it's $4,000. And after that, it's going to drop by 3%. So this is going to be 4,000 multiplied by 1 minus the annual drop, contribution drop. So I'm going to drag this down to the 5th year. Let's make sure that everything works. Okay. The total contribution. So the total contribution is, or the total margin for the car is the amount of car that has been sold. So that's the unit sales multiplied by the unit contribution. So that's, for example, whatever is sold in the first year multiplied by 14, which is the unit sale. which is the drag it down to here. All right. Next, we have the depreciation. So we said that the depreciation is going to be completed in 5 years. So that means that we're going to compute the 1/5 of the fixed development cost. So that's the fixed development cost divided by 5. And this is also the dollar format I'm going to use for it. I'm going to drag it down to the fixed year as well. So as you can see here, the depreciation is equal for the each year. Before tax profit, so the before tax profit, that's the total contribution that we have for selling the cars minus the depreciation that we can actually deduct it for. If you know finance, they can actually deduct depreciation from the revenue when they want to pay taxes. So that's going to be their revenue or the total contribution minus the depreciation, which is P16 here. And this is where they pay tax on. They pay tax on the revenue minus the depreciation. So that's going to be this value multiplied by 1 minus the tax rate, which is 25%. I'm going to use the format painter here. Okay, now I'm going to drag the formula down to the fixed year. Okay. All right. But for the cash flow, next is the cash flow. So depreciation is not exactly a loss. So now it's going to be shown again here. So the cash flow, the positive cash flow is going to be the depreciation plus the after-tax profit. So that would be the 18. And drag it down to the fifth year. So we have the cash flow for all the years. Now compute the NPV. So NPV is the net present value of all the cash flow that we have for the next 5 years, plus the cost or the cash flow that we have right now, which is the initial cost or the fixed cost of $800 million. Since this is a cost and the cash flows are positive, I'm going to have to use a negative value here for the fixed cost. And then I'm going to add the net present value by computing NPV formula. The first parameters here is the rate. So the rate is discount rate. And next we're going to just put the values here, the cash flow values, which is B19 to F19. Right. To get rid of the percentiles, decimal points here. So the NPV actually is our output. So I'm going to use the output style for it. Okay. It looks like we have computed everything that we wanted. The NPV is 36,000. Now, so this is just one replication for this. Next, what we need to do, we need to replicate this experiment many times. So if we want to do it, replicate it 1,000 times. Okay, so I'm going to do the replications here. Replications. One, two, three. And here I'm going to compute the NPV. Okay. So I have to make one space below the NPV so I can reference this NPV cell to the original NPV here. Okay. Now I can actually use the one-way data table to do that. So first, I'm going to generate 1 to 1000, showing the 1000 replication here. Okay. I have to do this. I'm going to grab all of the cells here in this table, one-way table, including the empty space on the left side of the MPV form. Okay. Then I'm gonna go to data, what if analysis, data table, and then because the values are going to be computed on the column, I'm going to skip over the row, go to the column, and here, because there's nothing to put here, but just reminding Excel to regenerate the random numbers 1000 times, I'm going to just click on any blank space anywhere. Okay. And when I hit OK here, it's going to replicate this experiment 1000 times, going to for each replication, it's going to compute MPV, and it's going to print it out here. So these are the values that you can see. I could use the format painter to format all the values that I have here, because they have to be dollar values, and I want to get rid of the decimal points. All right. So there we have it. We replicated the experiment 1000 times. And now what we need to do is to print out the summary of this experiment or simulation. Okay, so summary of simulation. The red one here shows actually a negative net present value. And these are what we want to compute. I want to compute the mean MPV. I want to compute the 95th percentile. And I want to compute the 5th percentile. And also I want to compute the probability that MPV is a negative number. Okay, so to compute the mean MPV, that's just using the average function here. So that's going to be average of B24 to B1023. So this includes all the numbers that we have generated over the replications. Okay, so that's the average is about $108 million. The 95th percentile to compute that, that's actually, it's gonna go and rank all the replications of the simulation for the 1000 replication that we have. It's gonna rank the numbers from the smallest to the largest in an increasing manner, and then it's gonna find the 95th percentile. That means that the number, that 95th percentile, which is 950. So it's going to be the 950th number when you arrange these numbers from the smallest to the largest in an ascending order. Okay, so it's going to give you the 95th percentile. So that's where the 95% of numbers or experiments here, replications here, are smaller than that number, and only 5% are bigger than that number. Okay, so to compute that, I'm going to use the percentile function. So it has few percentile function. I'm going to go to the oldest one. The oldest one is percentile just. So it asks for the range here, the range of applications, so which is going to be 24 to be 1023. So this is all the replication, and K is for the percentile that we want, which we want a 95%. So I'm going to put 0.95. So this is going to give us the number in these 1000 replications, which 95% of those numbers are less than this value, which is 103 million. Let me use the format printer for this cell as well. All right. The 5th percentile is the other way around. So it's going to, again, arrange all the number replications from the smallest to the largest, and it's going to find the 5th one percentile wise, so that 5% of the numbers are smaller than that, 95% are bigger than that. So that's the lower side of the spectrum here. Okay, so I'm going to use the same formula here: percentile and B24 to B1023, and the percentile is 5, so it's 0.05. And I'm going to use the painter format for that to make it to dollar value. So that's about 12 millions. But as you can see here, the number is changing each time that I click on the sheet here. So it's going to regenerate all the random numbers. Okay. So the 5th percentile is an important actually number. It's called the value at risk as well. So this is also VAR, or value at risk. So to compute the probability of the MPVs in our replication to be negative, what we can use is the COUNTIF function. So we're going to use the counting function, and we're going to count all the replications MPV values and count those that are negative. Okay, so I'm going to give it the range 24 to 1023, and the criteria is that we have a negative value. So I'm going to use the double quotation here, less than 0, and I'm going to close the parentheses here. So this is 28. There are 28 numbers that MPVs, replications for a movie, that they are negative. Okay, so to find the probability, I just have to divide that number by 1000, which is the number of replications. Okay, so, and this is not in a dollar value, it's actually in percentage, and it's about 12%, as you can see. Okay. Any question? All right. So let me go back to the PowerPoint slide. So we did that. Okay, we run 1000 replications. We examine MP numerical results and or histogram. We didn't do any histogram. We did the numerical. You can do histogram as well. It's not that difficult to do that. You just have to grab all the replications and then plot, use the histogram. So we found the mean, the average MPV value. So that was about $111 million. The 95th percentile is $206 million. The 5th percentile is $21 million, which is also the value at risk, and the probability of negative MPV is about 2%. So there's a question here. It says, what factor seems to have the largest impact on the MPV? So if you look at the model that we did here, everything that we computed depends on actually the unit cells here, the first unit cells, okay? Because the unit cells, so that was the first value that we computed. Everything else before that was just inputs. So that was a random number. We used the random number to generate that number. And everything else, like the unit cell after year 1, year 2, year 3, 4, 5, and also the total contribution, cash flows, the MPV finally, all depends on this value, okay, which is the first unit cell. So this is a telling that a good way to actually make a big improvement here is to somehow increase the unit cell in the first year and the next years by any means. that's possible, for example, by market. All right. So that's the model that we have. Hopefully the finance concept here wasn't too difficult. I don't think it was. Was just had a little bit of computation. We already had MPV experience with MPV. Here we have also depreciation. Depreciation is not a loss value, and it just used for corporations to pay actually less taxes. And so, right. Any question here? No question. All right. So that's actually we're going to close the simulation chapter. Anything after that, especially the Monte Carlo simulation, is just more advanced, and there are not a lot of problems that we can do in Excel. We have to use a specific packages or special packages that are for simulation. So we're gonna stop at here. So technically, our class is over, and also our lecture is over, and we won't have any more lectures. So we can work on examples or any problem that you have for example, for the next week, or you can just use the time to work on your project. Yes, Eric, go ahead.
Will there be a final exam after our group project?
Yes, there will be a final exam. Let me bring up my note here. So according to the university calendar, academic calendar, it is supposed to be on Thursday, December 15th. On the timing, we can actually, I mean, it depends on your time. So if the 6:30 to 8:30 works, 9:15 works, we can actually do that during our class time. Or if you're not comfortable with that time, you want to pick another time, we have to ask other students what they think. But I think we need to follow the university calendar and set timing, the date at least for the 15th of December. So it's going to be 2 weeks from now.
Would it be possible to have it like starting at class time at 6:30 and then extend it all the way till like before midnight, but with a 3-hour and 15-minute time limit or something like that?
Yeah, I have to think about it. Yeah, I'll consider it, and I'll send an email and I'll let you know. Yes, Salvador.
How exactly is the, I might have missed this, but how exactly is the final going to be structured? Is it like an exam, or are we going to have a simulation that we're going to be doing?
That's a good question. I actually don't know because as I told you in the beginning of the semester, this is the first time. So I'm building this course as I go through. So I haven't, developed the exam yet. So that's also a challenge for me, how to put together an exam here that is fair, that is also not a lot of work, but also a good test to, to check on your knowledge on how much this course actually helped you. How much did you learn from this course? So yeah, that's ongoing thing for me.
Our final group project would make a great final exam.
Yes,
I agree with that.
Yeah, that's all right. Yeah, but because other classes, they have exams. I mean, at least in my department, so I can't, I mean, it's not a good, I don't think it's a good like look for me to let my student not having an exam. It kind of is suspicious. I don't know. Yeah, it would be less work for me, right? Because I don't have to, if I just let you go with the project, then I don't have to design an exam for you and grade it. So it would be also less work for me. But there are certain things that I need to follow. Any other question? So I'm going to design the exam, and I'm also going to develop a study guide for you to help you, understand the whole exam, what is going to be in the exam, kind of help you to study for it. And if I have developed it by next week, Thursday, we can actually talk about it during the class. So we're gonna go over the study guide, tell you, how many questions I have in the exam, if I have done it by then. Okay. All right. Any other question, guys? All right. Thank you very much. I'm going to we're gonna have as I said, we're gonna have another. We're not gonna have any lecture, but we're gonna have like a meeting next week. So if you have any question about the exam next week or about your project or anything else, we can actually talk about it. So this is going to be the end of our lecture. I really enjoyed teaching this course. It was my first time, and I really enjoyed it. So thank you very much to be part of it.
Thank you, Professor. Good job for your first time.
Yeah, it's
Thank
been a
you.
pleasure.
Thank you,
Thank
Professor.
you very much.
Thank you.
All right. Have a great night, everyone.
Thank you, you too.
Thank you. Professor,
Good
can I
week.
hang back and ask you a question offline?
Sure.
Okay, thank you. So it's just about the function. I can't remember if you showed us in class or if you did. Hopefully I wasn't zoning out, but it's like the binom.inv function. I think it's used for like probability.
Yeah, no, we didn't talk about it in this class, but I have worked on it like 4 years ago in my probability and statistics class.
Okay,
Yeah, so
I think I might have.
This is for binomial distribution. If you remember from a statistic binomial distribution, it's like replicating an experiment that has two outcomes, like for example, 0 and 1, failing and succeeding. You have like two outputs, and you replicate it like, I don't know, n numbers. Okay, so n times, and you have the probability of success, and then it's going to tell you, what is the expected number of success, what is going to expect number of failure, etc. So that's the function for that. Yeah. What was your question?
Yeah, I thought, because I had been like, I was trying to use Google to like work on the assignment, and it was that was a suggested function. And so I was just like, it didn't really make sense to me. So I was like, I wasn't sure if that was a good way to go about it, or like how you get the probability